Okay, guys. So today I will discuss another technique to find out type 1 and type 2 error. Last time, if you remember, we discussed, casio fx 9860 for the distribution, binomial distribution, and there we saw how to find out the type 1 and type 2 error. But here I will tell you a very easy and quick skill using casio fx 9860 to find out the type 1 error. So there are some points which you need to keep in your mind. So if you remember these points, then it will be easy for you to find out the type 1 and type 2 error. So it's very simple, but you need to focus on, right? So whenever you will have a problem, either the problem is based on binomial or Poisson or normal distribution. So you will have two types of hypothesis, uh, null hypothesis, null hypothesis, and then alternative hypothesis. So this is the first type of hypothesis testing, where null hypothesis mean equals to c. C is any constant value. It may be any real value, okay, 1, 2, 3, or any real value, right? And there may be a condition when this mean is greater than c. Okay, mean is greater than c. So in alternative hypothesis, what is the null hypothesis? Null hypothesis mean equals to c, and alternative hypothesis, this mean is greater than c. Okay, and we have to check this at 5% significance level. Okay, 5% significance level means uh, in terms of the probability it is 0.05. Okay, so what you have to keep in your mind, what is the type 1 error? Type 1 error is rejecting h0 when h0 is true, right? So we have to reject h0. It means we have to find the probability. Okay, we have to find the probability of, so type 1 error means it's a probability of rejecting h0 when h0 is true, right? And at 5% significance level, in 99% cases you will have 5% significance level. So just this sign is very important here. I will show you. The sign is very important. Which sign? This sign. Okay, if it is greater than or less than, it decide the type of thing. Okay, so here you see the 5% will be somewhere here, suppose somewhere, okay, somewhere this 5% level here. Okay, this is 5% level, 5% level. Okay, 5% and 0.05. So here you have to find out the critical region. Critical region is this x value. You have to find out for which value of x there is a probability is 0.05. So we can use the inverse binomial distribution or Poisson distribution or normal distribution. I will show you how to use calculator, but before that you must know the concept. What does it mean? Okay, so whenever you have this type of problem, means you have to you have this greater sign and significance level is 5%. So in that case, what you will do, you have to put some points in your mind. Okay, so I will write on the screen. So what is required? What is required in inverse either binomial or Poisson and normal distribution? We need to write the value of the area. So if it is greater than, if it is the greater than this mean, it means this 5% is this one, and the rest of portion is 95%. It means we are looking for the 95%. Okay. So in that case, you will write area. Area equals to 95% or 0.95. But in case of the normal distribution, if you have normal distribution, so in normal distribution, you can see there are three options: left, right, and central. Okay, so you will always opt left. Normal, in case of you will always use left portion. Okay, and then area will be this 0.95. Okay, and rest of things will be given. In case of the binomial distribution, there will be total number of trials and probability of success. In Poisson, there will be average. In case of normal, there will be mean and variance or standard deviation that will be mentioned in the question. Okay, so this is the thing which you bear in your mind. So in second option, you will have this type of problem. Null hypothesis mean will be given some value, some constant or real value, or and yeah, and mm, this one, this alternative hypothesis here mean is less than this value C. Okay, C is an real value that will be mentioned in the question. So in that case, again, you will use the same thing, inverse, either binomial or Gaussian or normal left portion option only. So in this case, you will write area equals to 0.05. Okay, this will be the area for which we need to find out the critical value. So X is what? X will tell you the critical value, critical region. I will tell you this one how to find out for this is normal and or mm, binomial or Poisson distribution. Okay, that we will discuss one by one. But before this, you must understand how to use inverse binomial or Poisson or normal left, right? Especially the case in which we have to write the area 0.95 and the case in which we have to write the area 0.05. So one thing is very clear. If in alternative hypothesis, if mean is greater than C, so area is 0.95. And in second case, if in alternative hypothesis, if mean is less than C, so area will be 0.05. 0.05, this is because significance level is 5%. Okay, so most of questions will be based on 5% significance level, right? So we take some questions. Okay, let's we see this question number 2A from exercise 14P. This is based on binomial distribution. Here null hypothesis mean is given 0.6. In alternative hypothesis, this mean is greater than 0.6 and n equals to 30. Okay, and we have to find out type 1 error. So it's very simple. Here we will use, what we have to use. We will use GDC. In GDC, when you will use GDC, right, there you will write the area equals to, you will write, because it's greater than, so you'll write 0.95. Okay, so I will tell you how to write or how to use GDC. So I have written here the steps which you will follow in your GDC. First, you will press the menu, then stat, then distribution, then binomial, then inverse variable, and you will have this thing on your display of your GDC data. You will input your variable area. You will write 0.95, number of trial for this question 30, and probability of success is 0.6 for this question, right? Now we have to find out the critical region. So in case of binomial distribution, and one more thing, if this is, as we am talking, if this sign we have, right, if greater than, if this mean is greater than whatever mean is given in null hypothesis. So in this case, suppose critical region X, so the critical region, but in this case X will be greater than equals to A minus 1, right? It will be always less than one value from here, right? So A minus 1 equals to whatever you put this value in your calculator and you get some answer, right? So when you put all these values, this value in calculator, then you execute, right? You execute. So you get X inverse, you get X inverse INV equals to 22. Okay. So this you will write probability of X greater than equal to A minus 1 equals to 22. Right. You write this one. So here means you get A minus 1 equals to 22 and A equals to, that's why A equals to 23. So what will the critical region? So critical region will be X is greater than equal to 23. Okay, X is greater than equal to 23. So right, so we have to find out the probability for this critical region when X is greater than equals to 23. So probability of X greater than equals to 23. So this you will write 1 minus probability of x less than equals to 22 because 23 is included. But if you have some calculator are having the functions to write lower value, upper value. So in that case, you no need to do this one. No need to write this 1 minus, right? Directly you can find out putting 23 the lower and upper, 99. So you can find out that one. But since you are using Casio, this model does not have that function. So you will have to do like this way. And when you put this value in your calculator, you will get the answer. And this we are getting the probability of this x less than equals to 22. We are getting this one, and after deduction, we are getting 0.0436. So I think you know how to find out the probability of binomial distribution. Okay, this you will go for your reference. I am writing here. For this one you will go to stat, stat, but menu, then stat, then distribution, then binomial, since we are discussing binomial. Okay, so in binomial you will go to the bcd. Okay, you will go to the bcd, right there. This bcd, it will be written bcd, binomial bcd. So you will select, and then because this thing we have already in the class, you know how to find probabilities. So this one, okay. So this is the type 1 error. Okay, this is what type 1 error. This is type 1 error. Okay, type 1 error. Now type 2 error is very simple because we know the what is the critical reason. So type 2 error means, when we discuss the type 2 error, so one thing you need to keep in your mind. See, if you look at the question, there will be written. Okay, so type 2 error. You know what is the type 2 error? Type 2 error is probability of accepting H0 when H0 is not true. Means probability of accepting null hypothesis when null hypothesis is not true. Right. So here in first part we have got the critical region. Critical region was 23 and above. Right, 23 and above. If x is 23 and above, that's the critical region. So it means x the type 2 error means in the in the other region, right? Before 23, before 23. So before 23 means 22, 0 to 22, right? And probability, see that for the type 2 error, true value of probability success will be given, right? True value of the probability of that event, because it depends on what type of distribution is there. So like here you can see true value of probability of success is 0.6. so now I will take this one, probability of success equals to 0.68. Before that, for type 1 error, I was taking 0.6, right? As per the question, right? So here it means for type 2 error means x less than 23, where probability of success is 0.68. Or if you wish, you can write why 23, because the before the critical region. Or you can write probability of x, because less than 23 means what? 22, right? And when in case of this one, when probability of success is 0.68, right? So if you put this value in binomial bcd, so you get the value, this value is 0.792. Okay, 0.792. So this is the probability of second type error. Okay, probability of accepting H0 when H0 is not true, but in short we say this is type 2 error. Now question number 2b, we have, this is also binomial distribution. It's binomial, right? It's binomial distribution. So we have mean in null hypothesis, mean equals to 0.45. In alternative hypothesis, mean is less than 0.45 and n equals to 40, right? Number of trials are 40. So this test is being conducted on 5% significance level. So when you will opt the inverse, uh, right, inverse binomial distribution, there you will write the area 0.05. So procedure, how to use GTC is same like we did in previous question. So here we have to find out the critical region. We have to find out critical region, right? Critical region. So in case of this one, in case since this is less than, so what you will do, you have to find out the critical region, right? You have to find out a critical region, or you can say the largest value where you know x is, I mean the value of x. Yes, so when it means this is in case of if you are less than side, it will be a plus 1, right? So using GDC, like how to use GDC and what values you have to write, you just please look question number 2a, there we have. So all those steps you need to write over here. So if I'm using GDC, so I'm getting a plus 1 equals to 13. So a plus 1 equals to 13 means a equals to 12, right? A equals to, right. So it means type 1 error will be type 1 error will be we have got the critical region. So probability of x, right? X greater than 12, x greater than 12, and where probability we have probability of success we have point wait a minute, we have probability of success as sorry, this is type 1 error, it's not type 2 error. Okay, so type 1 error means this we are looking for the this region, right? Critical region. So what will be critical region? X less than equals to 12, probability binary is 0.45, right? So when I put this value in your calculator in GDC Casio, I'm getting 0.035858. So I can write this is 386, right? 0.0386. This is the type 1 error. So in case of type 2 error, type 2 error is simple, right? Type 2 error is simple. This is the because right this type 1 error means x less than equals to 12. So this is x greater than equals to 12. See, true value of this one will be given in the question. So true value of p here 0.43. Okay, if you look at in the question, so it's written over there, true value of p is given 0.43. So I will write 0.43, and this I can put in calculator and write the answer over here. Okay, so x greater than 12 means you will have to do this 1 minus probability x less than equals to 11. So use binomial BCD and you can find out yourself. So this calculation I'm leaving for you, right? You can do yourself. Yes, guys, if you look at question number 3, part A, so this is based on Poisson distribution. Here mean is given, alternate in null hypothesis mean is 4.6. In alternative mean is less than this 4.6 is very important, and true this given. Okay. So, but thing is here, as you know, uh, in case of Poisson distribution, you need to find out the actual mean as per the data. So new mean, there will be new mean because n equals to 30, 30 times 4.6, 0, 3, 6 are 18, 3, 4 are 12. Okay, so it will be 138 new mean. Okay. Now, in case of obviously, when you have to find out type 1 error, you will have to use inverse Poisson, right? What you will use INV Poisson in your GTC, right? GTC, use this one, and again same thing. First you will go menu, then stat, then distribution, then Poisson, then inverse Poisson will be there. I have already written in question number 2a. So same step, only the thing is that you will select the inverse Poisson. Okay. So when you select inverse Poisson, here important what area is there, right? So I will write the thing over here. Okay. So when you execute, you hit execute switch, you will get two values on your screen. Area 0.05 x inverse 119, area minus 0.0 1, then x inverse will be 1118. So okay, so here in this case you can take the area negative 0.01 because one value will be less than, so then directly you can write x inverse. Okay, x inverse x inverse equals to 118. Okay, you can take this value, right? Take this value when area less than, okay, less when area is just negative 0.01, right? In this case, this because one value will be less in this, in case of the to find out the critical region. So okay, so what will the critical region? So it means critical region will be probability of x less than equals to 108, sorry, 118. Okay, 118 118 118. So type 1 error means probability of probability x less than equals to 118 when the mean is given 138. Yeah, 138. So mean is 138. So you can using Poisson, right? Using Poisson, right? CD cumulative distribution, or PCD. You can find out its probability. You can find out its probability. So when I use GDC, I'm getting this is point 0458. This is the type 1 error, not type 2 error. So type 2 error means there will be a new mean for type 2 error because true value of mean is 4.5. Since there is 30, n equals to 30, it will be 30, new mean equals 30 times 4.5 is gonna be 135. So type 2 error is probability of x greater than 118 when mean equals to 135. So as per your calculator, you will do 1 minus probability of x less than equals to 170. You can do this calculation yourself. This is a question from normal distribution. Here mean in null hypothesis mean equals to 7. Alternative hypothesis mean is greater than 7. We have a number of trials, I mean n equals 30. Standard deviation is 0.4. So we have to make a normal distribution x, normal distribution n. You know, if you remember, this is mean and this is variance, but here we have n equals to 30, right? N equals to 30. So variance will be this over n, this over, right? So here it means this distribution will be x normally distributed, mean equals to 7. This is 0.4 over 30. Okay, over 30. 0.4 is square 30, right? This will be the normal distribution. Okay, so here you will have to use calculator again for type 1 error because you need to find out critical region first. Once you find out critical region, then you will be able to find out the probability of type 1 error, right? So now, okay, so when inverse, inverse normal. So data will be variable. Area is 0.95 because it's greater than significance level is 5%, right? So this is area will be 95%, means 0.95. Standard deviation will change then because this is a new normal distribution. So you can directly put this value in your calculator, square root, then use bracket because we are writing these whole numbers as per because it needs in your GDC. So this inside bracket I write this value, then I'm getting this much, and mean equals to 7, right? Then I execute. So when I execute, so x inverse I get 7.5. 1 1 2. Okay, so it means normal critical. What will be the critical region? So critical region will be probability this one. X is greater than, okay, critical region will be X greater than equals to 7.12, right? And we have to find the probability of this one. So it's only enough to write X greater than equals to 12, right, for the critical region. Okay, in the question is not asking about the type 1 error. So but let's find, we find out both types of error. Type 1 error will be, you can find out X, right? This distribution, so you will use yeah, distribution, right? X, same distribution here. I mean, here, this thing, I mean, mean will be 7 and standard deviation, I mean, will be this one, 0.7302, so, right? So in this one, you will use probability of X greater than equals to, right, greater than equals to 7.12, right, 7.12, and it's normally distributed when X mean is equals to 7, and yes, standard deviation, you can write this one, you can write zero point 0.4 square over 30, but when we will put value in calculator, that time, this one, right? So you can use calculator to find out this type 1 error. So when I'm using calculator, I'm getting this is 0.05, right? 0.5 and 0.174. So you will be surprised, for the normal distribution, type error is this 0.05, and it is what significance level. It is the significance. It is the significance level alpha, right? Significance level alpha. So, if you, that's why if you see the question in the normal distribution, question is not asking to find out the type 1 error. It's asking only to find out the type 2 error. So because for normal distribution and t distribution, for normal and t distribution, right? For normal and t distribution, distributions, type 1 error means alpha means whatever is the significance level, right? Significance level, type error will be same. Okay, that's why type 1 error is not asked in case of the normal or t distribution, right? So you have to find out type 2 error, right? As per the question, you have to find type 2 error. So type 2 error, you know what you have to find out. In this case, because the X will be less than 7.12, right? And yes, 7.2, and let me see, but there will be one thing change. Okay, so when you have to find out type 2 error, so only one thing will be changed. There will be new mean. So new mean is 12. Okay, sorry, by mistake I wrote here. New mean is 12, right? New mean is yes, new mean is 12.1. 12.1. Let me check. New mean, yes, 12.1. Let me see this question once again. Sorry, the new mean will be 7.1. Okay, 7.1. So we have this is X, right? Less than 7.12. New mean is 7.2, and variance will be same. So in this case, lower, when you open normal CD, lower will be -9999, right? Upper will be 7.12, and mean will be 7.1, and standard deviation, you already know this value, right? So when you put this in your in your calculator, you will get the answer. I think you would be able to find out. is the type 2 error. Try your calculator. So, okay, when I use my GTC, so I'm getting this is 0.60 at writing up to 3 significant figure. So guys, you can do all the question. Now this is you must know, it's not a difficult. You should have, if you have clarity in concept, what is type 1 and type 2 error, and how to find out, because in the beginning I have already discussed the rules. Just keep these points in your mind. It's easy to figure out these type 1 and type 2 error.